Hi everyone, today we are talking about specific heat. So what is specific heat? It's how much energy or heat is needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. We call it specific heat because it varies depending on the different substances. The units in the SI system are joules per gram degrees Celsius, or in the metric system it's calories per gram degrees Celsius. Essentially, what we're saying is that different substances heat up and cool down at different rates. So you can see here and here, these things are heating up and cooling down at different rates. So the formula is going to be Q equals mc delta T. So mass, Q of course is energy, we know that. M is going to stand for mass, which is in grams, right? So this should actually be here. C is specific heat. So we're going to use the letter C for specific heat. And delta T is final temperature minus the initial temperature. Okay, so that's going to be this whole thing. All right, Q equals mc delta T. Formula will always be given to you. Let's take a look conceptually at some specific heats of some substances, see what we can notice. So notice all of these are metals, and they have a really low specific heat. So what does that mean? It takes less energy to heat up metals compared to something like water. So just another reason water is special. Notice this big number compared to the rest, right? So what that means is this is less energy, whereas down here is high energy. So what that means is metals, right, heat up pretty quickly compared to water, right? So metals will heat up and cool down really quickly, whereas water takes a lot of energy to heat up water, and it actually takes a long time for water to cool down as well. If you've ever had a hot bowl of soup, you know exactly what I mean. And that's why I showed these pictures here. We've got a metal pot, right? We cook with metal instruments because they heat up quickly, and then water takes a while to heat up. And if you've ever made any food, like boiled some soup, you know that's true. All right, so you're gonna do a few problems. We'll start with these two example problems. So first example, how much energy, that's Q, would it take to raise 100 grams of a substance from 20 to 50 Celsius? So let's write down what's given. We don't know Q. We know the mass is 100 grams. And the change in temperature is going to be final temperature. So that's 50 minus 20 Celsius. Okay, so now we can plug all of that into our equation here. Q equals mc delta T, or Q equals mcat. And so I'm going to solve for Q here. I've got 100 grams. The specific heat of water is given. It's always going to be given to you if you need to use it. 4.184 joules per gram Celsius, that's Q, equals mc, and then change in temperature, 50 minus 20 gives me 30 degrees. So I punch all of that into my calculator, and I get 552 joules of energy. Notice the grams cancel out, and the Celsius also cancels out. Okay, so if you're solving for energy, you're going to get an answer in joules. Simply multiply 3 numbers together. All right, in our second example here, we're not solving for energy. We're going to be solving for, so this is degrees Celsius, specific heat. What is the specific heat? So we're solving for C here. If 24.8 grams absorbs 65.7 joules of energy, and the temperature rises from 20.2 Celsius to 24.5 Celsius. So I always like to write down, all the information we're given. We're not given specific heat, so we're trying to solve for that. We are given the mass, 24.8 grams, and we're even given Q, the amount of energy. We are given the temperatures, so the temperature goes from 20.2 to 24.5. So when you take the difference, the final temperature minus the initial temperature. So final minus the initial temperature. And cool, now we have everything we need to plug into our equation. This one's gonna involve a little bit more math, but that's all right. So Q is 65.7 joules. My mass is 24.8 grams. I don't know the letter C. And then my change in temperature, if I punch that in, I get 4.3 degrees Celsius. So I'm going to simplify this by multiplying these two numbers on the right side. And I get 106.64 times C is equal to 65.7. I want to solve for the letter C here, so I'm going to divide both sides by this number. And I get 0.62. We'll just round it off. Remember, the units are joules per grams, degrees Celsius, and that's my final answer. So this is a really small number, so I would suspect it's probably a metal. All right. That's how you solve these specific heat problems. Try the practice problems on your own and make sure you're asked questions.